In this video, we will discuss about count number of maximum bitwise OR subsets. So given an integer array nums, find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. So what they are saying is that in the question, we are given an integer array as an input. We need to identify the maximum OR that we can get out of these elements, right? And then how many subsets of this array have their elements or equal to this maximum OR. Then whatever is that count that you need to return as your answer. So basically we have two things here, that first we need to identify the maximum OR, right? And the next thing is we need to identify the number of subsets, right? The number of subsets having its elements, whatever elements are present in that subset, right? So having its elements or equal to this max OR, right? So these two things we need to identify, right? So first let's focus on how to identify the max OR of this array. So see, how does this bitwise OR operation behaves? So first let's create its truth table. So in the truth table we see that if the two bits are 0, then we get 0. If either of the bits are 1, then we get 1. And if both of them are 1, then also it is 1, right? So whenever we do the OR of two elements, right? Whenever we do the OR of two numbers, it will either set a bit or it won't set any bit, right? There won't be a case that the OR of two numbers unsets a bit, right? So if you will try to do the OR of more and more elements, then you would be increasing your chances of getting more set bits, right? And if you will get more set bits, then that means you are increasing your chances of getting a greater OR, right? So if you will do the OR of all the array elements, right, then you are only increasing your chances of getting a greater OR, right? So for finding out the maximum OR, we'll just do the OR of all the array elements, right? So now this is sorted. Now what we need to know is that how many subsets are there of this array whose elements OR is equals to this maximum OR, and whatever is that count, that is our answer, right? So if you see here, what are all the subsets of this array? So the subsets will be the empty subset, right? Then we will have the subsets where one element is present. So this 1, 2, 3, right? Then another will be that we have two elements. So it will be 1, 2, then 2, 3, then 1, 3, right? And another will be where we have all the three elements. So it will be 1, 2, 3, right? So if you will see that we have got a total of 8 subsets for this array, right? Now in these subsets, whosoever has its elements OR is equals to the max OR, that has to be counted in our answer, right? So what we need to do is, first of all, we need to identify all the subsets of this array, right? Now how are we going to do that? In your subsets, you will see that either an element from this array is present in that subset or it is not present, right? So if you consider this one, 1 comma 2, so here 1 and 2 are present but 3 is not present, right? If you see 1 and 3, then in this 1 and 3 are present but 2 is not present, right? So for finding out any possible subset, for every element we will have two choices. And what are those two choices? Either take that element or do not take that element, right? So keeping these things in mind, we will try to find all the subsets of this array. So first of all, let me give them the indexes. So it will be 0, 1, 2, right? So we will start with the first element, right? So initially we'll keep track of I equals to 0. Initially your index will be 0 and the element is 1, right? So first of all, we'll consider the element 1. So for this, we have two choices, right? Either we take it or we do not take it, right? So when you will take 1, then your subset will become an array having element 1, right? And when you do not take it, then it will be an empty array, or we can say the empty subset, right? So we are done with the first number. Now we will come to the second number in both these cases, right? So now your I will become 1 and your element will be 2 in both these cases, right? Now again for 2, we will be having two choices, either take it or do not take it. So when you will take 2, then here your array will become 1 and 2, and here it will remain as is, right? Then if you come at this point, if you take 2, then your array will become 2, and if you do not take it, then it will be an empty array, right? So now we are done with the second element. Now we need to check for the next element, which is 3. So in all these 4 cases, we will consider the next element, right? So I will become 2 now, and the element will be 3 everywhere, right? I will be 2, element will be 3, right? So again for 3 also, in all the cases we will have 2 choices, either take it or do not take it. So if we take 3, then this will become 1, 2, 3, right? And if we do not take it, then it will remain 1 and 2. Then here, if we take 3, then it will become 1 and 3, and if we don't take it, then it will remain as is, that is 1. Then here, if we take 3, then it will become 2 and 3, and if we do not take it, then it will remain 2 as is. And then here, if we take 3, then it will become 3, otherwise it will be empty, right? So now you will see that when we have traversed all the array elements, right? When we have checked for all the array elements, then at the last, we are left with all the subsets of this array, right? Here we had got 8 subsets, right? So these are those 8 subsets, okay? So if we traverse for all the elements and at every point we either take it or we do not take it, then at the last we will end up with all the subsets of the array, right? Now what you need to check is that what is the OR of this subset, what is the OR of this subset, what is the OR of this subset, and that whatever is the OR, that you need to compare with maximum OR, right? So now if you see here, do I need to store the subset elements? At every point I am storing the subset elements, right? Do I really need them? No. What do I need is, I need that at any point, whatever are the elements in your subset, what is their OR, right? If I store only the OR, then at the end here, so for example, for this subset, instead of 1, 2, 3, it will store the OR of 1, 2, and 3, which will be 3. Right, so I will be having all the ORs of all these subsets here, and I can simply check that whenever I have traversed all the array elements, just compare the current OR with the maximum OR. If both of them are same, then count this subset, otherwise do not count it. Then at the end, whatever is your count, that is your answer, right? So now let's code it out. So first of all, we need to find the maximum OR, right? So we'll take a variable max OR whose initial value will be 0. Then we will traverse in all the array elements, right? So I told you that for finding out the max OR, we will do the bitwise OR of all the array elements, right? So we will loop inside nums and we will do its bitwise OR with the max OR, right? So now you will get your max OR. Now we need to find out all the subsets and we need to check whether their elements OR is equals to this max OR or not. So for that, we will create a new function which will return us an integer denoting the count of the subsets having their elements OR equal to this max OR. So let's name it count subsets. So this will receive 4 parameters. One is the nums, right? Other one will be the index, the current index that we are on. Next is the current OR, right? And other will be the max OR, right? So here we will call count subsets and we will return it because it will give us the number of subsets which are satisfying our condition. So we will simply return it here. So it will take nums. Initially your index will be 0. Initially your current OR will also be 0, and then you will pass your max OR, right? Now in this function, count subsets, what you will do? So I said for each index, you will have 2 choices, either take it or do not take it, right? So if I write that when we take it, so int take, then that point we'll do count subsets and it will take nums, right? Now we have taken it, so index will be +1 now. We will move to the next element, right? So we will do index +1, right? Then your current OR will change because we are taking this current element, right? So what we'll do in the current OR, we will also do the bitwise OR of our current element, which is nums of index, and your max OR will remain as is, right? Other one is don't take it, right? So in this case, what you will do? Again, you will call your count subsets and then you will pass nums, your index will again increase by 1. But now we are not taking this element, so that's why our current OR will remain as is, right? And our max OR will also remain as is, right? Now at the end we can simply return that what is the count if we take it and what is the count if we do not take it. Then whatever is there sum, that we will return. Now when you will stop, what will be the base case for this recursion? So I told you that whenever you have traversed all the array elements, then you will be going to get the OR of that particular subset, right? So if at any point your index becomes equals to nums dot size, then that means now we have got our subsets. So now you will check that if your current OR is equals to the max OR, then that means you need to count it, right? So we will count this subset. Otherwise, we will not count this subset, right? So if any subset is having its current OR equals to the max OR, that will be counted as 1, right? And if it is not equal, then it won't be counted. So that's why we are returning 0, right? Now for any array having length n, its number of subsets are always 2 to the power n, right? The number of subsets of an array having length n is equals to 2 to the power n. So now what will be the complexity of your code? So here we are looping n times in our nums, right? And then here we are calling count subsets. This will run for 2 to the power n times, right? So your complexity will be n plus 2 to the power n, or we can say the complexity will be order of 2 to the power n, right? So now this time complexity can be reduced further. We can think of a better approach. So in the part 2 of this video, we will discuss about a more better approach for this problem. So now let's run this. So our test cases are accepting. Now let's submit this. So it got accepted. Thank you so much for watching. Please subscribe our channel.